How am I going to measure that source effect? Well, you will learn next week when you begin to do this, and in fact, we'll probably do an experiment in class. We can take a flask of air, which is about 400 parts per million. After you've been in the room for as long as you have, the CO2 concentration is probably close to 600 or 700 ppm. We can capture all that CO2 in the flask, and just like some of you have done in the lab, we can freeze out the water, we can freeze out the CO2, we can transfer that CO2 into a tube, and then put that into the mass spectrometer, which is what many of you in the labs will be doing. And by doing that, then we can measure what the isotope ratio is of the CO2. Now, you're going to do it in class next week as part of a lab because you guys are the source of CO2. I don't have a methane generator here, but I've got you guys. When you walk into the room, the isotope ratio of this room will be -8. As you sit in this room, what's going to happen to the CO2 concentration? It's going to go up. What's going to happen to the carbon isotope ratio of the CO2 that's in the air? Stay the same, go up, go down. You have a 33 1/3% chance of being wrong or right. It will go up. Okay. How many people think that the carbon isotope ratio is going to become more positive? How many people think it's going to stay the same? How many people think it's going to get more negative? It's going to get more negative because you're respiring your breakfast. Let's say you had a C4 breakfast. It was a -12. Let's say you were more healthy and you had oatmeal instead of cornflakes. That would be -28. So when you're respiring -28. Concentration goes up, the isotope ratio gets more negative. We'll show you how to use that information at the end of the class. So, botanists have done some wonderful things, and we've done some crazy things. So I need to give you the foundation, the grounding in the wonderful things that we do. We can express our data on carbon isotope ratio notation, the lowercase Greek symbol d, as you've seen here. And we're comparing the ratio, which is, remember, the ratio of 13C to 12C in the plant compared to the ratio of the 13C to the 12C in our standard. -1, because we don't like small numbers. We take that difference and multiply by 1,000, express the data on a per mil basis. All values for plants are negative. Okay? That's the tradition. But a very good friend of mine, Graham Farquhar, after saying "G'day, mate," decided that he would change the landscape. He said, "I'm really tired of not being able to separate the source effect from the biotic effect. So I'm going to create a new scale in which we remove the atmosphere, and we only look at the biotic effect." So what he proposed is an alternative way of looking at things in which we have positive numbers instead of negative numbers. And there's a very easy way to translate, but you have to do some of that translation in your head. So this is a good thing and it's a bad thing. It's good because it's nice to know what the true biological effect is. It's a bad thing because all of you guys here, you have sloppy technique. You're not going to be measuring the carbon isotope ratio of the air all the time when you're growing a plant. You're just going to say, "Yeah, I pulled it off the web. It's -8.2 today." And on the other hand, Shivankar in the lab is going to say, "Well, we measured the carbon isotope ratio of the air, and it's -9 in Salt Lake City today." 8.29, that's a 1 per mil difference. What's the big deal? Well, you're going to make an interpretation based on the wrong pieces of information. So it's good news and it's bad news. If you're going to use discrimination, you must be aware of what the atmosphere looks like. And how does it differ? He said, instead of comparing the sample to the plant, I'm going to compare the air to the plant. Now, you end up with, this is like looking at the world backwards, because you get positive numbers instead of negative numbers. But there's an easy way to make that translation if you want to. Just look at the numerator here in what he calls discrimination. And so if you're used to seeing something like a minus 28 for a carbon isotope ratio, minus 8 minus a minus 28 is going to give you a plus 20. So if you just say, okay, on average for the discussion today, I'm going to make the isotope ratio of the air 8 and do that or do that subtraction, you can make the conversion. Is it correct and appropriate? No. In fact, Turley would have told you it was not correct because it doesn't take into consideration this denominator. But for a ballpark, it's good. And I'm going to try to have on the same scale, the same graphics, both scales. Any questions so far? Yes, William.
Why is the variance less for C4 plants?
Why is the variance less for C4 plants than C3 plants? About 10:15, you'll learn the answer. Okay? Any other questions? I'm good at kicking the can down the road.